Fixed point and floating point types refer to integers and real numbers. We have already seen the type called int in Swift. This is a signed number, meaning negative numbers, 0, and also positive numbers. We also could have different precisions of int, and those are represented by int 8, int 16, int 32, and int 64, where the numbers in front of int here represent the number of bits which are used to represent the integer values. So int 8 here is the lowest precision integer type that we could have, whereas int 64 is the highest precision integer type. We could also use unsigned integers. Unsigned integers are represented by uint. With again, we could have different precisions of unsigned integers, as in the case of the signed integers. When we are using int and uint, the general formats of these two types, the precision of these two will depend on the precision of the platform we're using. For a 32-bit platform, int and uint would be the same as int 32 and uint 32 respectively, and in the case of a 64 platform, they will be the same as int 64 and uint 64. When we are using inference, when we're declaring variables and constants, Swift always assumes that the types of the constants and variables would be the same as int when the assignment, the value used in the assignment process indicates to be an integer. The floating point types include Swift's float and double. Double is a 64-bit floating point number, whereas float is a 32-bit floating point number. Again, when we're dealing with inference, Swift assumes double to be the data type to use. When we are typing in the actual values, in case of the numbers, 10, 100, or whatever, and in case of other data types, hello world, as an example of a string. So the actual values, when we're trying to type these in our Swift code, the terminology used is literals. In terms of fixed point literals or integer literals, there are a number of different representations that we can use: decimal, binary, octal, hexadecimal. If we are typing in a fixed point or integer literal of value 17 as a decimal number, we just type it in a familiar way. Whereas if we are trying to type in the same number 17 as a binary number, in other words, sequence of zeros and ones, we have to use prefix 0b before the binary representation of the number. Otherwise, without the prefix, Swift would understand this to be equal to 10,001. Similarly, for octal, we have to use a prefix, and that prefix is going to be 0O. And for hexadecimal numbers, we use the prefix 0x. So these four representations refer to this representation of the same number, 17. In the case of floats and doubles in Swift, the literals can be represented in either a decimal format or hexadecimal format. Example of a decimal format number is 122.0. If you want to represent the same number in a scientific format, we can use the lowercase or uppercase e followed by the power value, where e2 here means 10 to the power 2. Similarly, in the case of hexadecimal numbers, we use p instead of e to represent a power of 2 number. So for instance, the hexadecimal number a, which is the same as decimal 10, can be represented as hexadecimal 5p1, which is effectively hexadecimal 5 times 2 to the power 1. And there are situations that we may wish to convert a number of a certain data type to another data type. For instance, a float to an integer, or an integer to a different integer data type of a different precision, int 8, int 16, and so forth. So the way to do that is just following this syntax, where we have type, which is the data type that we wish to convert to, followed by parentheses, and within parentheses we have the value that we want to convert. An example here is where we have x1 declared as a variable of type int 8, and then we have x2, a variable of type int 16. We cannot simply add x1 to x2 to create another variable called x3, because these are of different types, and in Swift we are not allowed to use two different values of different types in the same statement unless we do something to it. And that is the process of conversion that we were talking about. So here we are converting x1 from this data type, which is int 8, to int 16 first. And once that is done, the new number is going to be an int 16 number, and we can add that to x2, which is already an int 16 number. And by way of reference, Swift will determine that the type of x3 is also in data type of x3 is also int 16. So that was the example of an example of integer to integer conversion. We could have, as another example, conversion from double to integer. For instance, if we have a variable called y1, which is of type integer, and y2, which is of type double, if we wish to add these two up, we have to first convert one of these two to the type of the other number. In this case, we are converting y2, which is a double, to an integer. So the outcome of this conversion would be an integer, which can be added to y1, which is also an integer. And again, by way of inference, Swift will determine that y3 is also of type integer. Let us complete this tutorial session with a number of examples on the topics we've already covered in Xcode. Here we have the three different ways of declaring and assigning values to variables or constants. The first case is the separate declaration and assignment. So we are declaring a variable called name1, which is of type string, and then assigning a value to it. This line of code shows the simultaneous declaration and assignment arrangement that we already discussed. Um, and again, we are having a variable called name2, which is of type string, and we are assigning a value to it on the same line of code. Thirdly, we use the inference arrangement. So we have a constant this time called name3, and we are assigning a value to it on this line. And then finally, we are showing here the usage of print function when we are printing this message on screen, and at the same time including the values of variables name1 and name2 and the value of constant name3 in the message, with the outcome showing down here. So notice here that James, Sam, and Kate are the values of these two variables and constants that we assigned in the code above. Next, let us have a look at various integer formats that we discussed previously. Some examples are shown here. So let's get rid of this first part that we already discussed. Now, here we are declaring a variable called x1, and it's of type integer. Now here I'm just trying to show what is the precision of int1. So in order to find that out, one way to do it is by just assigning a value to x1, which is equal to int.min. So what this does is Swift sort of finds the minimum value that an integer can have and assigns it to x1. Similarly, if we use int.max instead of int.min, we can assign the maximum value that an integer can have to x1. So the outcome of these assignments are shown here. So in the case of int.min, we see this very large negative value, and in the case of int.max, we see a positive value, which is almost the same as that. It is one less. So effectively, you can see that int values range from a negative of some value to effectively the positive version of the same value. Now, the next thing to look at is unsigned int and see what the range, what is the range for unsigned int using the machine that I am using. So again, using the same argument as above, we find the minimum and maximum value of unsigned integer values for this machine, and the minimum value is obviously 0 because we're dealing with unsigned integers, and the maximum value is this number. If you look at it carefully, you can see this is effectively twice this value. Now, x3 is declared as being a variable of type int64. Again, the minimum and maximum values are shown here, and if you compare these with the first two values that we computed before, you can see they are identical. So that indicates that our machine is actually a 64-bit machine, because as we discussed before, the precision of int is the same as the precision of the platform that we're using. And so for that precision, these are the minimum maximum values for int, and int 64 also has the same minimum maximum values. So there we can deduce that our machine is a 64-bit machine. Now, as a very final example for this case, we look at int 8 values, and we can see that for minimum and maximum values of integer 8-bit integers, we get -128 to 127, which can easily be calculated anyway. It's just a confirmation of that. Now, next, let's have a look at some literals and their representation in Swift. Here are some examples. In the first case, we have a variable called y1, which is of type integer. As I'm using the same example as I was using in my slides. So here we are assigning a decimal value of 17 to our variable, the y1 variable that we declared above. Then this is going to be the binary version of the same value, octal version of the same value, and hexadecimal version of the same value. You can see that the decimal versions of all these values computed by Swift are all 17. So these are the representations of the same literal, namely 17. Now in the case of doubles, I'm declaring a variable z1 to be of type double, and then assigning different values to that variable. 112, the scientific version of it, again the scientific version where I'm using capital E instead of lowercase e. And finally, there is a third variable declared here as double. The name of that variable is y2. And then the first case is a non-scientific representation of the decimal 10, which is 0xa. Now, the scientific representation of that using lowercase b and uppercase p are also shown here. Again, we can see that all these represent the same number. The same also applies to the previous example, where we can see that all these three representations are representations of the same number, which is 112. As a final example, let's have a look at the case of data conversion. The example that I have in mind is effectively the same as what I showed in my one of my slides, and here it is. So what we are having is we are having three variables. First two are declared as integers, with the first being of int 8 type and second being of int 16 type. If we wanted to add these two numbers together and assign that to a third variable called third int, we could not have done it directly. So if we had done it directly, we would see a runtime error. So here's when they're added directly, and we see this red circle, which is indicative of a runtime error. So in order to avoid that error, what we need is we have to convert one of those values to so that its data type is the same as data type of the other value. In this case, I'm converting first int, which is of type int8, to become of data type int16. Once that is done, this value, the whole thing, will be of type int16, and the second int was already of type int16, so we can add them up and assign that to our third variable, which is called third int. So as we can see here, there is no error. 5 is the value of first int, 300 is the value of second int, and the value of third int is correctly calculated by Swift to be 305. So this was an example of integer to integer conversion. Next, let's have a look at an example of conversion of a double to integer. So here's the example. So we have three variables. First one is an integer, second one is a double. We try to add them together, but in order for the addition to be valid, we have to convert one of the values so that its data type is the same as the other value's data type. In this case, I'm converting our double to an integer using the same syntax as we have used before, and as a result of this, the sum of these two will also be an integer, which would indicate that our sum should also be an integer. One thing to notice here is, unlike the previous case where I did not explicitly mention the data type of sum, I am doing that here. So what is happening here is I'm just saying that I explicitly want the sum to be of type integer, and as the result of our addition is already an integer that agrees with our data type of sum, and we will see no problem whatsoever. We now have reached the end of the second part of our tutorials on the basic concepts of Swift. In the next part, we will be discussing more of the basic concepts of Swift, including the Boolean type.